Okay. To start out, just a little bit of an overview. There are a couple of different stages along which this whole process of developing and testing hypotheses uh, moves along. And you can see that initially you start out with looking at literature, reviewing it, and from there identifying gaps within that literature. And once you identify those gaps, well, what other work is there that maybe has already filled in those gaps? So you go back in, do a little bit more literature review, and this is a sort of iterative process, as it's called. And once you get a pretty good idea of what's going on, then you can start to develop a research question. But of course, once you do that, well, is there information about that particular question that's already been investigated by previous scientists? And so you kind of go back and forth in this in these three sort of stages. Once you settle on a good research question that you feel that has not been explored yet, then you can start to develop an actual hypothesis and your design, then collect data, analyze the data, and report your findings in either a dissertation for most of you, or a journal article, or some other type of paper, report, manuscript, etc. And the methods that, what's going on? Okay, the methods that you use are going to determine upon these first initial stages. If there's little previous research, you're going to be looking at a more exploratory study. If there's been a lot of previous work, you're going to want to basically confirm some relationships or explore more nuanced relationships between variables that are of interest to you. And I'll talk a lot more in depth about what each of these stages entails as we move forward. But let's start over here at the beginning with the literature review and identifying gaps in the literature. So for most of you, the very first step is basically to go to the TCS library website, and from there, just search databases. So there's a great little tutorial that shows you how to navigate to the library. I'm not going to go through that. You can obviously feel free to use this link for your own purposes. What I'm going to do, though, is just kind of show you when you actually get to the website for the library, which I'm hoping should open, but perhaps not. Bear with me.
Hello, Kuba. Can you mute everyone because we are getting some feedback?
Oh, yeah, sure. So, yeah, if you want to ask questions, then I would say just type them into the chat box because I won't be able to hear you. Okay. Hopefully that makes the feedback issue better. Okay. What I'm going to do is simply go to the website. There it goes. Okay. So this is the window that you should see, and eventually, when you navigate to the eventually when you get to this home page of the library, there's a little sidebar here, and you want to go to search our databases. And here you'll see that there's a huge list of different databases that we have access to. So these are more useful than others. Some of them, obviously, there are some that are labeled as psychology. So Psych Articles is probably one of the best ones. Psych Info as well. The nice thing is that up here at the top, EBSCO is the publisher of all these databases. So there's actually a sort of overarching way that you can search all of the psychology ones. And so here you can search by things like title, author, subject. One of the main ones that I want to draw your attention to is keywords. And keywords are basically what you should be using to search for a topic like depression, post-traumatic stress, attachment style, what have you. And then you'll refine your searches as you go forward. Once you start learning more and more about what it is that's at the core of what your particular field of psychology is interested in. And so one thing that I should note is that what we're doing here is searching this EBSCO database. And you'll see that over here it says searching PsycInfo. You can choose the databases that you want to search through. So you can check all of these to greatly expand your search criteria. But that's a little bit too much detail for now. The point being that this is the resource that you should start with in terms of getting your lit search started. Okay, so like I said, EBSCO and Psych articles are two really good ones. Obviously, there are others that you should look for if it's of more or less interest to you. And again, the Chicago School website, the library website, tells you what each database is really sort of specific to. Okay, so like I sort of briefly mentioned, you can enter keywords, authors. There's all kinds of different criteria that you can search for. And when you search for them, you can review the titles that show up and the abstracts that show up. So each of those pieces of information is going to help you basically understand whether or not it's a relevant piece of literature for you. So the ones where it is a relevant title, the abstract looks really interesting and pertinent to your current question, go ahead and download that article, read the full thing, the full text article, book, chapter, what have you, and from there you can basically start getting an idea of what's, again, known about your specific field. And what's also important to do is to look at literature that you find inside of that first piece of literature that you downloaded. So you read an article, it's got an introduction, everything sounds great, and they're citing a bunch of studies and talking about what the implications of those studies are for their current study. So you obviously want to look at the literature that is being cited by other authors, and then that's the first piece here, studies cited by the current articles that you're finding, but also studies citing that current article. And, well, how would you know that? How would you know who's citing this current article that you're reading? The previous ones are obviously, they're going to have a references section, but for finding out how to find work that has cited yours, I'm just going to look for myself very quickly. And when you search, so you found a study, right? And now once it actually shows up, I'll show you what I mean by studies that cite your particular article that you're reading. So you find an article, and here it's loading. Okay, so you'll see that here, let's say that this is the article I'm reading, right? And in this article, there are going to be a bunch of references, and I can find those previous articles. But what's been done since 2012, right? This is when this article was published. You'll see that in this particular database, PsycInfo, it's been indexed, and people who also are part of this network, if you will, have cited this study. So you can click this link for any article that you find and see, okay, well, what has the literature done? What have people done in the literature since the time of this publication? And here are a couple of articles that have cited it since then. And so now this is a way for you to get sort of up to date in terms of what your particular research topic is all about, what's already known through today. Now, obviously, if you go to a different database, for example, in Google Scholar, I know that because I'm kind of obsessed, I know that it's been cited 4 times. So there are other ways to find this out. But certainly this is sort of the strategy that you should follow. Okay, so back to the slideshow. When you start doing this process, you should pretty quickly start to get an idea of where you are in this galaxy of your topic. However, that's not always that easy. I mean, maybe you're there, or is it here? How do you really know? There could very well be literature out there that you are going to be unable to find because a certain set of studies doesn't cite a different branch of the same field, how do you really know where you are in terms of what you need to know? Perhaps an iceberg would also be an apt metaphor. The idea is to look for road signs. You want to see within this particular area that you're starting to become interested in, who are the most frequently cited authors. You can obviously search databases by author. You can visit authors' websites and look up their publication records and find out what work has been done by that particular author or group. Typically, well, not typically, but a lot of the time what happens is that you'll actually see that there's only a limited group of people who are studying the same phenomenon. And at that point, it might be easier to search by what they've done over the years. As opposed to looking for topics and keywords, look at it in terms of what a particular group has done, because they'll be focused on the same topic over time. You should also be seeking highly regarded literature. When you read certain articles, book chapters, etc., you'll see that there are certain sort of milestones that were hit by certain authors, and you'll see these little clues. For example, in a seminal study, Smith, 1982, discovered that, and then you know that you need to read that study by Smith, 1982. You go to the references section of whatever this particular citation would be, and find that Smith, 1982 piece, go into EBSCO, find that full text, read it, know it, love it. And of course, there's other kinds of phrases that authors will use. For example, our results are consistent with the now classic theory of, and then whatever the case may be for your area of interest. But these articles are out there, and they're always sort of pointing you to what's the important literature. So it's definitely something to pay attention to. Don't just skip over the introduction sections. Definitely make sure to wrap your head around what the important issues are. And so this is just one way to do that, in addition to looking at the important authors. And another great strategy is to look for review articles and meta-analyses. A review article is basically something that sums up the current state of knowledge in a field. And the more recent it is, obviously, the better. But certainly within the last few years would also be very useful. And again, you can look for articles that cite a review article, like I showed you, and find out what's been done since the most recent review. A meta-analysis is kind of like a review, but it actually quantifies relationships between variables. So that's a very useful tool to try to see how robust a certain effect is. So if you're looking at let's say there's a meta-analysis of veteran status and PTSD, you would want to know how strong that relationship is. So a meta-analysis would actually take as many studies that the authors could find on that given topic and basically quantify how strong the relationship is between veteran status and PTSD. If it's not a strong relationship, well, that tells you one thing. If it is a strong relationship, then that will obviously lead you to refine your research question in terms of what kind of minutia of that relationship are you going to be interested in. Because if it's already been done, you don't want to be doing redundant work. And I'll talk a little bit about that in a little bit. So what ends up happening is that the more you learn, the more you realize how much you don't know. As soon as you answer one question, it opens up 10 more. So that might be, maybe a little bit disheartening, but, Albert Einstein himself didn't take this problem too seriously. So the takeaway message here is that the results of one lit review will lead you to the beginnings of the next one. So you revise your search according to those clues that you gained in this iterative process, and you look for the keywords, the instruments, the authors that everyone seems to agree is, providing the most useful research. You should definitely find out what keywords are used. Any article that you download and start reading, you'll see that they'll have a list of keywords that they used. Right on the first page of the PDF or printed article, what have you, they will list the keywords. So those are a great way to start. Instruments, meaning what scales are they using, what methods are they using, and those you should also keep in mind as you're going forward, because that will later on in your hypothesis development and your research question development help you start to identify the variables that you can actually measure. And of course, like I said already, the authors who you start to learn are the sort of big hitters in the field are the ones who you're going to want to start citing. And of course, like I said, it's an iterative process. That's what those back and forth arrows are really focusing on, is that just because you've done one lit search doesn't mean that you've found the final answer for your particular question. You'll get clues, but it's often a matter of revising your search for new questions that pop up along the way. So you're trying to learn more and more and more so that you can have this outlook instead of a negative one. Okay, so what happens when you start to get to the end results of your lit review? It could turn out that there's a lack of evidence on your topic. There's a question I just noticed. So before I talk about this, yes, the question is, can you search for meta-analyses as a criterion? And yes, you can. There's a great feature in EBSCOhost where you can refine your results. And here, if you click Show More, there's a huge list of different criteria. So where is it? Publication type. No, it's in here somewhere though. Document type. I think this might be it. Perhaps not. Oh, it might be under methodology. That would make sense. Can I not scroll? Here we go. Yeah. Okay. So we've got meta-analysis. So you can search for that. Obviously, when I search for okay, it's thinking. Anyway, yeah, so if you had keywords here and then you selected meta-analysis down here, that would be one way to narrow down the results. Because if you search for a keyword, you'll get thousands of hits, but if you narrow it down by meta-analysis, then it will hopefully give you only a few. Obviously, it's not going to find any results because I have not written any meta-analyses. But if you search by keyword and PTSD, for example, or let's just say keywords depression, there's going to be some results. Okay, but this is taking forever, so I'm going to just minimize out of here. Okay, so, and obviously there are different criteria that you can search by in EBSCO. So anyway, so what happens when you start to get a sort of idea of what's going on in the literature? Let's say that you've iterated a few times, you've looked at all the stuff that's super interesting to you, and it turns out that there's a lack of evidence. Another option is that there's converging evidence, like I briefly alluded to. It could turn out that everybody understands everything about your given topic, or there could be conflicting evidence. If there's a lack of evidence, that's actually really good because it means that it's now your turn to pave the way. Your dissertation can really break some ground in terms of finding out what's really going on in this field that you're interested in. If there's converging evidence, it means that everybody's starting to find the same patterns. Everything is sort of coming together into a cohesive picture. Again, you don't want to conduct a redundant study. If there is converging evidence and you're still really interested in this topic, there's something that you're finding that it has not been addressed, this is where you're going to want to reiterate your research question in light of what is already known and change your original research question. Maybe not change, maybe evolve would be a better term. Certainly refine what you originally thought you wanted to study and make it more focused, essentially. And this is where hypothesis testing is really going to start to play a role. If you have conflicting evidence, you want to investigate what's different about these different studies. If they're finding different things, what is it that's different about these studies that could be causing conflicting results? It could be the measures they're using, could be the populations that are being studied, it could be any one of a number of things. But when you put two studies side by side, they're studying the same construct, they're probably using different methods, they're studying different populations, what have you, and they're getting different results. So what is different about them that could be leading to the conflicting evidence? And that in and of itself could lead you to understand your topic better and in fact develop a hypothesis about those differences and directly study those differences. Okay. And I should mention, just want to reiterate that any one of these patterns could be the case. So it's up to you to find out what's really going on. Okay, so once you develop a research question, then you move into generating a hypothesis, a testable hypothesis as it's called, from that more general research question. And so sort of piggybacking off the previous slide, if there's little scientific knowledge about a topic, you don't really have a hypothesis per se. This is where you're going to develop sort of open-ended exploratory questions that will typically lead to a qualitative study that could potentially use open-ended interviews, structured interviews, things of that sort, where you're just trying to get an idea of what the experience of your participants is. On the other hand, when there is robust converging evidence, like I sort of alluded to, you want to posit a precise hypothesis. When you have a very well-studied phenomenon, what it really starts to boil down to is examining really nuanced aspects of it. And that's where this idea of precision comes into play, is that you're going to test something very, very specific about this phenomenon to sort of add to this robust converging literature that's already known about the topic. But when there's conflicting evidence, again, you want to posit a hypothesis about what the potential source of variability in the results is. So again, when you compare two studies or two sets of studies, you should start to think about what it could be that's causing divergent results. And again, I can't really get too specific because it's really going to depend on any given area of inquiry. But when it comes to hypotheses, what you start to get into is hypothesis testing. So you have a research question, you want to know about a certain topic, but a hypothesis is something that will actually give you some sort of quantifiable measures that you can use to test whether or not there are significant relationships or significant differences between groups, between variables, what have you. And what you always start out with is what's called the null hypothesis. The shorthand for this is H sub 0, 0 being null. And there's, of course, an alternative to this, which is literally called the alternative hypothesis. And what an alternative hypothesis says is that there is a significant relationship or a significant difference between groups or between variables. And there's two types of alternative hypotheses. They can be either non-directional or directional. A non-directional alternative hypothesis is basically saying there is going to be a difference. And that's different from a directional hypothesis, which says there is more in one group versus another. So the specific difference is that you're predicting which group or which comparison is going to be more prevalent, is going to be higher on some measure, and that's directional. Higher and lower are obviously like two ends of the same spectrum. Non-directional is not making the same prediction. It's just literally saying that there is going to be a difference, but you're not predicting which group is going to be higher on some measure, lower on some measure, etc. And just like there's a shorthand for the null hypothesis, there's a shorthand for the alternative hypothesis, which is either H sub 1 or H sub A for alternative. Either one is fine. And let's talk a little bit about what kinds of relationships you could be exploring using hypothesis testing. You can look at just basically trying to describe what's going on, and you can observe rates of different behaviors and quantify those and posit a hypothesis about higher or lower rates of these observations that you're making. You can do correlational research, where you're basically measuring the strength of relationships between variables. You know, you've got, for example, I don't know, time since return from a tour of duty and the amount of PTSD symptoms, and look at the relationship between those, quantifying it, and then again making a directional or non-directional prediction about whether or not the amount of PTSD decreases over time or increases over time. So that would be a directional hypothesis. And then you can also do quasi-experimental comparisons, which is looking at comparing different groups on the same measure of interest. So this, for example, could be comparing veterans to non-veterans, or let's say Vietnam veterans to veterans who are just coming back from Afghanistan, and comparing those groups on whatever measure you're interested in. And experimental, this last category that you can use to test a hypothesis, is really less pertinent to a lot of research that goes on, because what you would have to do here is, if we're talking about PTSD, for example, you would have to randomly assign people to like a high PTSD condition or a low PTSD condition, and you would never ever want to do that. Why would you do that to someone and induce PTSD in them just to study the effects? That's not ethical, so don't do it. However, some folks will be doing experimental studies, and this is where you would basically randomly assign people to groups and then test for differences between those groups that you've controlled. And so there's a sort of spectrum of what types of research designs you could implement to test your hypothesis. However, the focus of this talk is not on that specifically. We have other talks that are on the NCADE website where you can where we dig into these types of design issues in more detail. But for now, I want to focus on actually testing a hypothesis regardless of its method of approach. For any study, any quantitative study, you have some criteria for having a good, solid study, a valid study. First of all, you want to use valid and reliable instruments, meaning that when you go into your literature search and you find a certain instrument that you want to use, you want to make sure that it's one that is not susceptible to measurement error, that hasn't been criticized for a lack of reliability and validity, so on and so forth. And I'm going to go into each of these 5 points here in detail. You also want high integrity data, meaning that you want to make sure that the data that you actually collect is entered correctly and isn't susceptible to any kinds of artifacts that will impact your data analysis. You also want to have sufficient power to detect any effects, and I'll talk about how power analysis impacts your ability to make conclusions about your hypothesis. You also want to have statistically significant effects, and this is closely related to power, and I'll talk about that as well. And finally, you want to have effect sizes as part of your reporting. And this goes sort of hand in hand with statistical significance, and I'll talk about the differences between those as we go through. So let's start with instruments. Choosing a valid instrument, you want to make sure that whatever instrument you're choosing, whether it be a self-report scale, whether it be a measure of anxiety, whether it be a measure of anything at all, you want to make sure that it has internal and external validity. Generally speaking, internal validity is the degree to which an instrument actually measures the concept or construct it is intended to measure. If you want to use a measuring cup to measure someone's height, it's not going to work. If you want to study PTSD, you probably want to get a measure of PTSD and not necessarily something like depression. They might be sort of related, but you have to keep in mind that your construct is going to be measured using some scale, and you want to make sure that that scale is internally valid, i.e. it measures the construct that you're actually intending it to measure. On the other hand, external validity is a degree to which your internally valid results can be generalized to other contexts. So if you're studying, Afghanistan veterans, for example, and you find some patterns, how generalizable are those patterns to other groups of veterans? If they're coming from Afghanistan, they're more recent than even Gulf War veterans, and they're going to be different than Vietnam veterans, and so on and so forth down the line. So depending on how you structure your study, you have to keep this concept of external validity in mind as you go through your discussion section, your chapter 5. Okay, so that's validity. Reliability is a little bit different. Reliability is the degree to which the instrument produces consistent, stable indication of the level of a variable. So let's unpack that a little bit. What are levels of a variable? Well, let's say that you're studying, again, PTSD. And what you have is an instrument that's been used in previous studies, and they found that with the same population, let's say Afghanistan veterans, they find similar patterns for that group across time. That's test-retest reliability, and that's really, really important because if at 1 week after returning from war, you get one pattern of results, and then 8 days after returning from war, so just from testing them on day 7 to day 8, and you get a completely different pattern of results, there's going to be a problem. So you don't necessarily want to go for any kind of instrument that hasn't already been validated in terms of its not only internal validity, but also these issues of reliability. So whether it's across time or across research teams, this is what inter-rater reliability pertains to. If you have multiple groups and they find conflicting results, well, that's really going to be a problem because it suggests that there's something about implementation of that instrument that is not robust against having different people use it. So these two criteria are very important in terms of choosing an instrument. And the way that you quantify reliability is using these, typically these 3 different methods. Cronbach's alpha tells you about an instrument's, the questions within an instrument, how they all basically go together. If there's a high value, that means that they're all related. Factor analysis is a similar method, except it looks at the factor structure of a questionnaire. So don't be surprised if you see these used in the same type of study. And finally, meta-analysis, like I mentioned, it will sometimes be used to analyze a certain instrument. So there'll be a meta-analysis of an instrument, and you'll see that they indicate how reliable a certain instrument is. Again, tying back to the lit search, of course. Okay, so we talked about validity and reliability of your instruments. What about your own data? When you go to collect your data, you're going to have statistically inevitable transcription errors. Let's say that you have questions that range from, strongly disagree to strongly agree, and that corresponds to values of 1, 2, 3, 4, and 5. And when you're coding your data into SPSS or Excel or whatever software you're using, and you by accident put a 6, well, you're going to have to go back and check and make sure that that hasn't happened. Because if you do include a 6, obviously that's going to skew your results, and it's going to be impossible to draw a valid conclusion if there's a lot of these errors. So that's sort of the very first step, is to make sure that you're not having missing values or erroneous values. So don't forget to check your data for these types of issues. And then you actually have to test what are called statistical assumptions. Without testing these, your actual data analysis and therefore your test of your hypothesis will not necessarily be valid. So there's a few general assumptions that are pertinent to any kind of quantitative study. The first assumption is that your data are missing at random. And within the SPSS environment, all of these tests are available, and I'll just kind of briefly touch on them, but these are things to just remember to check for. And there are going to be specific nuances depending on what kind of, if you're doing a correlational study, there's going to be different assumptions than for a quasi-experimental study because you're looking at the variables in different ways, so on and so forth. We don't have time today to go into that in too much detail. But what you're going to have is to analyze the pattern of missing data. You're going to have to check for normality of distributions using visual inspection of histograms and what's called the Shapiro-Wilk test in SPSS. You want to check for homogeneity of variance. If you're comparing multiple groups, that's what you use Levine's test for. And you also want to look at influential outliers. If you're doing a regression-based framework where you look at Mahalanobis distance, and I dare you to say that 3 times fast, and also standardized DF betas. These are measures of how influential outliers are. And speaking of outliers, here's the big problem with outliers. If you are looking at a set of data, let's say that this is time since return from Afghanistan, and this is amount of PTSD using whatever reliable, valid measure you want to use, and this is your pattern of results, right? So the longer a veteran has been back, the more PTSD there is. So you got this generally upward trend. If you have an outlier, so someone who's falling way outside the rest of the data, the degree of influence that this outlier has can be more or less. If this particular outlier were to be closer to this line of best fit, as it's called, then it wouldn't be that big of a deal. So basically, even if there's a lot of time that this veteran's been back, but they have a lot of PTSD according to the measure, then it really fits with the rest of the model, and that's not really that big of a deal. But if they are skewing this line of best fit, then you really have to start worrying about what to do. Because is this person representative of the rest? Not really. So you have a few options. And I'm not going to go into details of these, but basically you can transform your variables to bring this outlier closer in to the rest of the data. You can simply remove the outlier, or you can use what are called non-parametric tests, which basically rank all the data and close the gap between all of your data points, not just the outlier. Again, not enough time to go into these in detail. But point being, you shouldn't be analyzing data that you haven't fully checked for integrity and applied these sort of remedies. Okay, so now let me talk a little bit about power. A power analysis basically comes in 2 forms. The first form is where you have to determine what your necessary sample size is going to be for your study before you conduct your study. So basically the general point here is that as sample size increases, so does your chance of detecting effects in what are inherently noisy data. You're always going to have variability. One person is going to have PTSD just as much as another person, but they might report it a little bit differently. So you're always going to have this variability, this noise in your data. So as your sample size increases, you can start to cut through that noise, basically. But how many people do you actually need? Well, you have to review the extant literature that's related to the construct that you're interested in, and basically look for how many participants were used in a study to find a significant effect. And if you happen to see that there's sort of a minimum number that everybody uses, that's a really good clue that that's what you should also be doing. However, all studies, well, more recent studies, probably since around the year 2000 or so, have started reporting what effect sizes they found. So if you start seeing things like Cohen's D, Pearson's R, or this little squiggly n squared, which is eta squared, you should definitely take note of those. Because when you go to do a power analysis, it will require you to say, okay, well, what effect size are you expecting to find? And depending on the answer to that question, you're going to need more or less participants that you'll be able to quantify using G-power. So this is where once you have information from the previous literature of what to expect, then you use this G-Power software, and you can go to this website to download it. It's free. It's not very user-friendly, but it's free, and it's also the sort of standard at this point. So definitely go ahead and download that. And then you can calculate the necessary sample size given the expected effect size and the number of variables that you're going to be using in your specific design. Sometimes it's 2, sometimes 5. That's really going to be, on a case-by-case basis. So you conduct this a priori power analysis, and then you know that when you go to test your hypothesis that you will be able to reliably evaluate whether or not a significant effect can be trusted, or if a non-significant effect is in fact non-significant, or whether you actually were just unable to cut through the noise because you didn't have enough participants. Okay, so once you do all that fun preparatory work and you collect your data and you go to evaluate your hypothesis, what is this value of p is less than 0.05? What is that actually trying to get at? So what we're doing is, remember I mentioned earlier that the null hypothesis is always the starting point. The idea is that you have to start out with the assumption that there is no effect. And it's the burden of proof is to demonstrate that there is an effect, and you have to start out with this assumption. So if there is this assumption of no effect, what is the probability of obtaining the difference that your data are demonstrating? And the logic is that if that probability is less than 5%, then you can no longer, the assumption that there's no effect is no longer tenable, basically. So you start out with this assumption that there's no effect, and then you try to show that that can't really be the case. So if the probability of obtaining your effect, if there is no effect, is really small, then we have to conclude that, well, guess what? There probably really is an effect. And this 5% criterion is just something that everybody agrees upon. So that's what we use. Some are more stringent, some are less stringent. But in any case, if you demonstrate that this probability is really small, then you have to reject the null hypothesis. So that's really where that's why everybody's looking for that gold standard of p is less than 0.05. But what about effect sizes? Great, you can have a significant effect that doesn't really, have much of an impact. If you have a treatment that you develop and you study 1,000 veterans in one group and 1,000 veterans in the treatment that you implement, and you see, a 1% decrease in PTSD symptoms, is it really that meaningful of an effect, even if it is significant? Well, that's what effect sizes tell you. So for example, here's what I just mentioned, right? Like, let's say that the yellow line is some token intervention and the purple line is this novel intervention that you're studying, and the peak is where most veterans are. So you can see that there's a really small difference, right? Most people are just a little bit away from each other, and obviously you're going to have a distribution around that mean. But as the effect size becomes bigger and bigger, each of these 4 examples is statistically significant. But obviously the one with a bigger effect size is the more impactful intervention. So that's what effect size kind of tells you. Well, not kind of, that is what it tells you. It either tells you the amount of variability in the outcome accounted for by your predictor. In this case, it would be the treatment that you're implementing. And this is what eta squared and Pearson's R tell you. Or it'll tell you the distance between distributions. This is what this little set of examples actually pertains to, which is typically using Cohen's D. So there's just some examples of effect sizes. But notice that the p-value only tells you whether you can reject the null hypothesis or not. What an effect size tells you is, well, how big of an impact does a significant or even a non-significant effect have? You can have a non-significant effect but still have a large effect size. It's counterintuitive, but it can happen. So both need to be reported, basically. All right, so now power analysis is where you are able to, after the fact, determine what your power to detect an effect was. And whereas before, remember I referred to an a priori power analysis. Now, after you've collected your data, you run what's called a post hoc power analysis, and you're no longer using expected effect sizes. Now you're using your own obtained effect size. So when you run your statistical analysis in SPSS, you can ask it for effect size and then plug that effect size into G-Power and say, okay, now that I know specifically what my study was, how likely is it that, that my results are trustworthy? Like I mentioned before, small effects are difficult to detect, and if your power is low, meaning less than 0.8, and I'll explain that, you should be very careful about making conclusions and taking your results at face value. Okay, so first off, what does it mean for power to be less than 0.8? What this means is that if you ran a study 100 times, your exact study with the same number of participants and the same variables, same instruments, everything, a power of 0.8 means that you would detect your effect 80% of the time. So 80 of those studies would detect the effect and 20 would not. And just like P is less than 0.05 is taken as an agreed upon criterion, this power level of 0.8 is also agreed upon as a criterion for having achieved good power. So if it's less than 0.8, you want to sort of hedge your discussion of whether or not your effect is in fact real. Now, if you conducted an a priori power analysis and you collected the right amount of data, you should be just fine. Okay, and so the very last thing that I want to mention is that, again, this talk is pretty general, but depending on how you structure your own study, you will get the proper analysis that will be needed. So if you have continuous or categorical predictors, you can have one or multiple predictors. You can have one or multiple categorical outcomes, one or multiple continuous outcomes. Whatever the case may be, you will find the right analysis. So the idea is to first focus on what you're really interested in, develop your hypothesis, and the appropriate statistical test will be there when you get to that point. So don't try to reverse engineer it just because like you've heard of a correlation or you've heard of a t-test. You shouldn't try to fit your research question into the test. The test will fit your question. And with that, I want to thank you for your attention and take any questions. I know that we started late, so unfortunately we only have time for a few questions, but I'm happy to have you type in questions, and then I can actually unmute you individually so that you can ask your question to the audience. Let me just try unmuting folks who might be on the phone. We'll see if there are any questions. Okay, so there's a question, please give an example of quasi-experiment. So this goes back to the types of questions that you can basically ask using different types of designs. And quasi-experimental studies are where you have multiple groups, but you do not manipulate the group membership. So this is where you can have, for example, males and females, and you can compare a male group to a female group, and that difference already exists out in the world, so that you're not, you know, say manipulating who is male and who is female. That's kind of impossible. Another example might be looking at veteran status. Someone either is a veteran or is not, and you can sample them from the world and compare those groups, non-veterans to veterans. The difference between that and an experimental study is if in an experimental study you would basically manipulate people's veteran status. So you would randomly assign people to either go to war or not go to war. And I don't really think that you could pull off that study in an experimental framework. So hopefully that makes sense. I've again unmuted everyone just in case people want to shout out some questions. Okay. In that case, I thank you all again for your attention. And if you do happen to have questions about any of this stuff or would like help with your research, please reach out to us. You can visit the website there or shoot us an email. And we also have a phone number that you can call if that is the preferred way to communicate as well. Okay, let's see. There are a couple more questions. So if people want to hang out, I will still be here to answer these next few questions. The question is, what about a mixed method design when using qualitative data to develop quantitative constructs? You can certainly do that. All of the ideas in this talk would pertain to the quantitative aspects of a mixed method design. So if you're using qualitative data first to develop an idea of what's going on, that's fantastic. And from there, not just using literature, but using your own qualitative analysis, you could then develop a hypothesis that you would test using the same principles that I outlined here. Then there's another question pertaining to the quasi-experimental design again. Does it mean you don't have a fully randomized sample? And yes, that is what that means. You could theoretically randomly select participants from, a veteran group or a non-veteran group, and essentially that is very seldom really done unless you have a ton of resources where you can actually sample a population randomly. What typically happens is that you would have a convenience sampling procedure where you have, say, a PTSD clinic from which you can choose to randomly invite a subset of veterans or, whatever group. I'm just using veterans as an example, right? But you can invite them to participate and do it that way. So you never really would realistically have a fully randomized sample. So hopefully that addresses your question. Then there's another question about what is the best way to test reliability. Well, it depends what kind of reliability you are interested in testing. So what I would say is, if you're interested in retest reliability, then basically you should just really look in the literature and ensure your readers that it is in fact been, excuse me, that this measure has in fact been previously validated, and they will report their measures of retest reliability. So when you go to look at review articles, definitely keep an eye out for that. If you're trying to develop a questionnaire or some other measure, then there are different ways to test that. If that's your question, then just give me a follow-up. And okay, here, yeah, I'm scrolling down. I can see that you're elaborating. I want to use archival data and apply existing instruments in order to develop a construct based on that data. I think the best thing to do at this point, these are very specific questions. What I think we should do actually is have you email us and schedule a consultation with a methodology expert. And that will give us an opportunity to talk about in depth what it is that you're trying to do. But for the purposes of this talk, then I think it's best to just kind of leave that for a consultation. Okay, yes, you're welcome. I know not everyone can hear me. I'm having a sort of one-way conversation myself, but this person and I are just kind of communicating via the chat window. Okay. All right. So anything else? And thank you. I'm getting all these thank you messages in the chat window, so thank you all for the feedback. I greatly appreciate it. Okay, so if there are no more questions, I will end this meeting. So thank you all again, and this will be posted soon on the NCADE website. So if you want to revisit this, then that's certainly an option. So again, thank you all, and that's it.